morning, I am Chen Chongyin. She is Randy Li. Today, I want to introduce our project, dividing a circle with the least curve. There are some defined symbols. S is the unit circle that we need to divide. A generalized circular arc means circular arc or a line segment. The function L is the length of the curve in the bracket. Radius method is dividing S as required by radii. First, we have proved radius method is the best solution of the problem dividing a unit circle into two equal parts. Now, I would like to discuss the problem of dividing a circle into two unequal parts. There are two possible cases to divide the circle. The first case is impossible due to by isoperimetric inequality. The minimum cut must be a circle. We will talk why it is impossible later. In the case 2, a curve which is n on the circumference of the circle. We use the lemma 7c. If L is the shortness curve with n points which may not be fixed on the circle dividing a circle into two parts, then the curve is generalized circular arc, and the region with the long major arc must be convex. We use the lemma, so the curve must like this. By calculus, we found out the expression of dp d theta. At last, we discovered that if the sum of angle theta and phi is equal to pi over 2, the curve attains minimum in case 2. Next. We draw a graph to compare two cases. In order to find the solution, we draw the function area over the square of perimeter. As the ratio of case 2 is larger than case 1, for any value of p between 0 to pi over 2. Therefore, orthogonal generalized circular arc is the solution of the problem dividing a circle into two unequal parts. We use above results to find the length of cutting a part with area pi over 3 when using orthogonal generalized circular arc. The value is around 1.893. It is used to investigate the next problem. Then I am going to discuss the problem of dividing a circle into three equal parts. There are 5 possible cases to divide the circle. The first 4 cases are not the best solution. By isoperimetric inequality and the lemma 7, the results are shown. For case 5, a y-shaped curve, we have used some symbols. The curves are called alpha, beta, and gamma. The length of alpha is the shortest, and they are linked in anticlockwise direction. Big gamma is mean the union of alpha, beta, and gamma. And radius method is like the second picture. And it is used the radius to cut the circle, and alpha is n on the point 1, 0. X theta is stand for the result of rotating x by theta anticlockwise through O point. We have to prove statement 20 first. Firstly, we draw a straight line from intersection point of the curve and radius to the end of circumference. Then we draw a straight line from point D to the end of circumference. But from our point, radius method is the best solution. As statement 20, if D is not O, there exists phi such that big gamma cap big gamma phi, then the length of gamma is longer than radius method. However, this statement is too strong, so we need to prove the existence of the necessary condition of statement 20. That is statement 27. If big gamma is minimum and D is not O, then there exists a phi such that big gamma cut big gamma log phi. We have prepared statements 21 to 26 to prove statement 27. For the statement 21, if alpha is not generalized circular arc, we can find a point which is either on a segment of non-generalized circular arc or a joint of two generalized circular arcs. We can draw a circle at this point and replace the line by generalized circular arcs. Repeat to do it, then alpha and beta and gamma become generalized circular arc. For statement 22, if the big gamma is minimum, it must shorter than using radius method, so it is smaller than 3. For statement 23, as the alpha is the shortest by statement 22, so the length of alpha is shorter than 1. For statement 24, we use the previous results, then the proof is shown in the PowerPoint. For statement 25, we consider the triangle between point O and the intersection point of curve and radius. We use the previous result, then we get the result that alpha is included in the sector of S with angle theta less than 90 degrees. We prove statement 26 by contradiction. We consider 5 cases which are not obey this statement. The first 3 cases are shown. The area in these cases must not equal to pi over 3. In case 4, beta cut OA log twice, cut OA log theta, and cut OA log 90 degree none or twice. We consider the red area which is smaller than pi over 4. For the green area, as semicircle has shortness parameter, we imagine these 2 semicircles. Then we use the previous result to prove it is smaller than pi over 3. For the case 5, beta cut OA log theta and cut OA log 90 degree once. As the green curve does not cut the line of 90 degree. And so we find the radius by reflection about the line joining 2 center of 2 circles. Then we can compare these 2 closer paths which is in green area. We treat this area as a donut shape and move it to the top. Then we calculate the area. We get the result that the area is more than pi over 3. Since these 5 cases are impossible, by contradiction, beta must cut the sector OB log theta. But we want to know how beta cut the sector. These are all possible cases. In case 3, there are an intersection point, and in case 4, the area must be larger than pi over 3. In case 1 and case 2, it shows that there exists fire such that big gamma cuts big gamma fire. So the statement 27 is true. As the necessary condition of statement 20 must be true. So by Fermat point, radius method is the best solution. For the problem dividing a circle into 4 equal parts, we want to disprove radius method is the best solution. By Euclidean-Stigner tree problem, y shape would be shortest distance between points. So we calculate the length of this shape, and it is shorter than 4. Therefore, radius method is not the best solution. This is the end of my presentation. Thank you for your attention.